Hello ladies and gentlemen. Today we're going to do pre-calc lesson 15, assumptions and proofs. Yay, more proofs! We will get into a lot more extensive detail about proofs today. So be prepared because it will be quite a bit of writing. So let's talk about some tools for proofs. Okay, all of the definitions that I have given you, right? Those are things that you need to know so you are able to use them in your proofs. Today we will be going back through postulates and axioms. Okay, and these are things that are accepted without proof, meaning if you were to state one of these, that could be your reason. You don't have to prove it. We know that these are true. And theorems, which we can prove with these above things. Okay? And there will be some times when we will prove things that we have already accepted as true. Now, there's a distinction between assumptions. Okay? An axiom is true in all areas of math. Hands down, always true. But a postulate is applicable to a specific type of math. We call it a branch of math. Okay? Now, we went over this a little bit last year. This year we're really going to use it. Euclid's postulates. Euclid's top 10. Now, these are very important. You do need to know them. Okay? Let's go through them again. 2 points determine. A unique straight line. A straight line extends forever and ever. It extends indefinitely in either direction. A circle may be drawn with any given center and radius. All right angles are equal, which we've used this before in different proofs. And number 5, given a line N and a point P not on that line, there exists in the plane of P and N and through P one and only one line M that does not meet line N. Right? So I'll draw a picture for you on the next page. Okay, so I have this point P and I have this line N. And we're saying that there is a line in the plane up here that goes through P. This is line M. And there's one and only one line that will not intersect N. This is talking about parallel lines. Okay? All right, let's keep going to the other half. 6. Things equal to the same thing are equal to each other. We know that is true. If equals are added to equals, the sums are equal, right? If A equals B, B equals C, actually let's say C equals D, then A plus C equals B plus D. That's all that that's saying. And in the reverse, if equals are subtracted from equals, the remainders are equal. Number 9, figures which can be made to coincide are equal. If you were to take two figures, let's say my hand is a figure, my other hand's a figure, and I can lay them directly on top of each other, that means that they're equal figures. That's all that we're saying there. And 10, the whole is greater than any part. Again, that's something we should know is true. All right, now, couple more things. 2 more ideas or tools for proofs. Okay, the median of a triangle. The median of a triangle is a segment connecting a vertex to the midpoint of the opposite side. So, I have this triangle. This is my median. It connects to the opposite side, and it connects to the midpoint, which means those two halves are equal. Okay? And then one that we've been using for a while, reflexive axiom, everything is equal to itself. Okay? So let's do some proofs. Okay, example 1. We want to prove that the median drawn from the vertex formed by the equal sides of an isosceles triangle bisects the angle at its vertex. What are we trying to prove? So here's my picture. I have an isosceles triangle. Okay, and I'm drawing this median, which by definition of median, I chop these. I'm trying to prove that this angle equals this angle. Now, you might already be able to see the proof, but we have to go through and state some things. Statements, reasons. Okay, our first thing is we have to talk about all details. Okay, so let's label this ABC. We say in triangle ABC, AB equals BC. And this we could say given definition of isosceles. It's kind of both given and isosceles because it tells us it's an isosceles triangle, but we're stating which pieces of the triangle are the actual isosceles. Okay, and let's say BD is a median. That's given. Okay? But we know since it's a median, AD is congruent to DC, definition of a median. And we can see that BD is congruent to BD, reflexive property. Okay? Then I can say triangle ABD is congruent to triangle CBD by side, side, side. So angle ABD is congruent to angle CBD, CPCTC. And we're done. Okay? This is very similar to what we've been doing before, but this time we don't have stated out, these are our given, this is what you're proving. You're inferring things from the paragraph they tell us. All right, let's do another. We want to prove that if two tangents to a circle, they intersect at a point outside the circle, we want to prove that then the lengths of the tangent segments are equal. Okay? First things first, always, always, always draw a picture. Okay, so here is my circle. Let's call it circle O. And I have this tangent intersecting with this tangent at a point. Let's call that P. Let's call this A, B, points of intersection. Okay? Now, the hard thing about a proof like this is you have to remember all the definitions I gave you about two tangent lines intersecting. Okay? So, the first thing is we have to state that AP and BP are tangent to circle O, sorry. This is our given. Okay. Now, I know that if I was to draw OP and OB, OA and OB are congruent. You could say OA is congruent to OB because they are radii. Okay? And then the key is I know that OA is perpendicular to AP and OB is perpendicular to BP because that was the definition of tangent, right? Definition of a line that is tangent to a circle touching the radii. Okay, so now I'm going to draw this line here to give us two triangles so we can prove this. Okay, and I know that these are equal. I also know that OP is congruent to OP, reflexive. And if that's true, I can say that triangle APO is congruent to triangle BPO by hypotenuse leg. Therefore, AP is congruent to BP, CPCTC. Okay? Again, you have to be able to draw the circle and the picture and what does it look like just from that paragraph. And we have to know the definition of a tangent touching a radii. That was from 2 or 3 lessons ago. Okay? All right, let's do another. prove the sum of the measures of the angles in a triangle is 180. All right, so a triangle, I have ABC. Okay, so this is really hard because we have to use Euclid's postulates. Okay, now one of our postulates says, Euclid's fifth postulate, that if I have a point up here, B, and I draw a line through it, I can have these lines, the line through B and the line AC, be parallel. Okay, so I'm going to add another point here, D, so I can say BD is parallel to AC, Euclid's fifth postulate. Now we are using Euclid's postulates. Now angle 1, angle 2, angle 3. I know that angle 1 plus angle 2 plus angle 3 equals 180 because it's a straight angle. Okay, now I have two parallel lines cut by transversal AB. So I can say that angle BAC is congruent to angle 1 because they are alternate interior angles. Same thing, I can say that BCA is congruent to angle 3 because they are alternate interior angles. Told you guys those wouldn't go away. And now look, I can say that the sum of the measures, so I'm going to say angle BAC plus angle BCA plus angle ABC equals 180, since angle 1 plus angle 2 plus angle 3 equals 180, which we also know, right, that if two things are equal, we can add them in together. Okay, so this is also by substitution. Ta-da! Okay, Euclid's postulates, now they're coming to get you. All right, let's do another example. This one says use the sixth and eighth postulates to prove vertical angles are equal. So I'm going to draw my vertical angles. You have to draw a picture every single time. A, B, C, and D. Now, it's a good thing that we learned Euclid's postulates last year. Hopefully you didn't forget them. Okay. Now, my first thing I need to state is angle C and angle A are vertical angles. That's given, right? We can't prove that vertical angles are equal unless we say that we are working with vertical angles. Okay. The next thing I'm going to say is angle A plus angle B is 180, straight angle. And angle B plus angle C is 180, straight angle. Then, right, since these both equal 180, I can say that angle A plus angle B equals angle B plus angle C, because Euclid's sixth postulate, Euclid's sixth postulate says things equal to the same thing are equal to each other. And I know that from here, if I have angle B on both sides, I can cancel angle B, leaving me with angle A equals angle C, and that's Euclid's 8th postulate. If equals are subtracted from equals, the remainders are equal. And we're done. We proved that two vertical angles are equal. Okay? Again, if you have any questions, you need to bring it to class. Okay, now there's another proof for an example, but I'm going to do that in class tomorrow. So that is all for today.